Algebra 1, Chapter 1, Section 3, Properties of Numbers. There's normally in a normal class setting, we'd write all of these numbers, all these different properties down over and over again. You have them all in your book. If you want to write them down because it helps you remember them or put them on note cards to help memorize them, perfectly fine. All of these ones I'm going to show you are on page 16 and then a couple of other pages. But if you're in this section, you'll see these big key concept things. So I'm mostly going to talk about them. I'm not going to write them down during the video. That would take too long. You all have them in a book. Put them on note cards and try to memorize them if that's what you like to do. You need to know them. I'm not going to say don't worry about not memorizing them. You need to know them, but choose the method that's best for you. And the context of it is more important than the specific definition. The big idea of what we're going to be working on today with this lesson is this idea of equivalent expressions. 4k and 8 plus 8k is the same as 12k. They're the same expression, they're just written out slightly differently because they're represented in different ways. We have to have rules, just like order of operations, on how we can manipulate these things so that we can always find when two expressions are equivalent or equal to each other. Here's some of the properties from page 16. You've got the reflexive property, and that basically means reflexive, think like a mirror, something is always equal to itself. So like 7 is always equal to 7. Pi is always equal to pi, right? That's just what it is. Symmetric property, that means you can, if you have two different expressions that are equal to each other, 5 equals 2 plus 3, you could also write 2 plus 3 equals 5. That's what the symmetric property does. It allows you to change which order it is. You probably have seen it from your math teachers in the past. If they're ever like solving an equation, they solve it all down and they get like 5 equals x, but on the very last step they just write x equals 5 and then they box that, even though it was on other sides of the equation. They were just applying the symmetric property really quick. I know I do it all the time, just like out of my head. That's just what we do. The symmetric property is just so ingrained in everything that I do that I can do that real quick without thinking about it. The transitive property is something like, if you know, I'm going to reuse your example here because it's nice and easy. 6 plus 9 is the same as 3 plus 12, all right? And 3 plus 12 equals 15. Do you see how the two parts in the middle here match? They're the same thing. That means you can skip over them. 6 plus 9 equals 15. Now, what we usually see this is with variables. I know x equals y and y equals 5. So I'm going to skip over this part here where we have both y's, and then I'm going to just write x equals 5. That's the transitive property, and that's more commonly how we use it. Substitution property, you've already used it before. If you know that like there's a specific value for something, they have, n equals 11, and you have 4n, well then you know that that value of n, 11, can just get plugged into it, and it turns into 4 times 11. It's basically just doing what we did in the last example and telling you the rule of why that worked. So, hold on a second here. This is actually supposed to be the number 0. Oh, I got a bad font here. You can't tell that it's a 0. I'll fix that real quick. Oh, let's not do Georgia, because apparently that's a bad font. The number 0 is a very important number. you can add it to anything and it doesn't change it, right? 5 plus 0 is still just 5. So we call it the additive identity. It doesn't change the identity or value of anything when you add it. We also call it the additive inverse because if you take a number like 5 and you add its additive inverse, -5, you get 0. And that's actually how you find out that what something's additive inverse is you think, whatever number you just gave me, what can I add to it to get 0? And that's how you find the additive inverse. Just like additive inverse and additive identity, there's multiplication versions of those. You're probably already familiar with it. 1. 1 is the multiplicative identity. If you take any number and you multiply it by 1, you get the same number in result. If you take a number and you multiply it by its multiplicative inverse, 1/5, you get 1. Actually, sorry, I wrote that down here. That's for the third row there of the table. Again, to find the multiplicative inverse, all you have to do is say, I've got a number, what do I need to multiply it to get 1? And that would be the result there. The only time that doesn't work is when you've got yourself this scenario here, 0. Like I said, 0 is very important. 0 is the additive identity. It also has to have a special property for multiplication. Anytime you multiply something by 0, you get 0. And 0 does not have a multiplicative inverse. That's one of the reasons why you're never allowed to divide by 0. We just don't allow that to happen. It causes problems, right? If you allow a number to be divided by 0, I can tell you 1 equals 2. And if 1 equals 2, then what's any of it matter? So there is no multiplicative inverse for 0. It itself has its own special multiplication property. When you multiply anything by it, it becomes 0. So that's a brief highlight of all of the properties. You're going to want to have your page open or have those written down for when you do the problems, because all the problems are going to be based on those different steps or those different properties. Now, we're going to evaluate using the properties. And I've got a numeric expression, 7 times the quantity, that's how I tell you it's parentheses, 7 times the quantity 4 minus 3, minus 1 plus 5 times 1/5. Now all of those things together, there's no algebra in it at all. We're just going to be using order of operations to evaluate it. And here's what I would like you to do. This is why I was trying to encourage you to do one step at a time. We're going to do this one step at a time. And then from there, we're going to name the properties that we use for each one. So evaluate using the properties. 7 times 4 minus 3 minus 1 plus 5 times 1/5. Now, I look for grouping symbols. Yes, I have some parentheses right there. 4 minus 3 is 1. So I'm going to do 7 times 1 minus 1 plus 5 times 1/5. Now I look for multiplication. For multiplication, I'm going to do from left to right, 7 times 1, which is 7, minus 1 plus 5 times 1/5. Do I have any other multiplication or division? Yes, I do. I have 5 times 1/5. And from there, I have 1. Now, here's something. I'm going to pull a little aside over here. 5 times 1/5. What's actually happening in that problem? Well, any whole number like 5 really is being divided by 1. And if you remember how to multiply fractions, you do the top times top, bottom times bottom, or numerator times numerator, denominator times denominator. What is 5 times 1? It's 5. What is 1 times 5? 5. 5 divided by 5? It's 1. I just combine all those things together. Hopefully you might know right now already which property I just used there. That's why it was so easy for me. But if you ever need to break it down, that's how you can handle that. All right, now I have addition and subtraction. Um, well, let's do. I'm going to do something interesting here, and I'm going to kind of break one of my rules and not do it left and right. No, I'm going to do it left, right. 6 minus 1, or sorry, 7 minus 1 is 6 plus 1, and then I get down to 7. Now, what they really wanted you to do there was 7 minus 1 plus 1, and see that the minus 1 plus 1 is the same as adding 0. That's what they were trying to get you to do, but there's a part of it that they haven't actually had gone over yet in the book. If you see that, though, negative 1 plus 1 together, you see that, oh yeah, just turn it into that, and now you've got the problem. Now, I've got all of my stuff here, and I'm just going to turn it into a table. I've got each step along the way. Okay. And the very first step was just what I was given, right? I just rewrote the same problem. This is given. What did I do in the first time? I just added, right? Or, sorry, I did subtraction there. That was, oops. 4 minus 3 is 1, so subtraction. Next up, I multiplied 7 times 1, but 7 times 1 is a special kind of multiply. If I look up here, that is the multiplicative identity, because it was times 1. So that's what I'm going to write down here, multiplicative identity. And if you want to abbreviate identity with ident, perfectly fine by me. Next up, we have we went from the 5 times 1/5 to nothing. So that's something special that's going on there. That's the multiplicative inverse. I multiplied two things and it became 1. Multiplicative inverse. And then I had 7 minus 1. That was subtraction. And 6 plus 1, that's addition. Now, in the back of the book, they can probably combine the negative 1 and the 1 together, and you would have had the add inverse, and then you would have had added them together and gotten 7 and have the additive identity. So you can see there's multiple ways to do these problems. If you miss some of the things, as long as you describe them correctly and you notice the big ones of like, oh, I multiplied two things, got a 1. That's important. Then you're good to go. It doesn't have to match the back exactly. When you turn in problems with the selected problems, I will be able to read your work and know what you're doing, and I'll just mark you down. Like if you just said between these steps here of 7 times 1 down to 7, if you just said multiplication, I'd mark you down because that was a special kind of multiplication, the multiplicative identity. But otherwise, I'm not going to worry if you don't do the most efficient route. That's fine. This is kind of a longer video, but it's a bigger step here. And we're not going to do these things forever. They're just kind of last for this section, maybe the next section, and then on the chapter test and the Unit 1 exam. After that, though, we're really not going to use this for a very long time. But it's important to practice to know why you're doing all of these things. So that was a longer video. Make sure you take a smidge of a break after it before we go into the next one. But I'm going to go right into it after this.